All right, so this week we're going to start off looking at the end of chapter 2. There's some sections we might skip over, but we're only doing 2.3 and 2.4. Okay, so I think last time we did 2.1, we skipped 2.2. So it's just the way we do the sections in this class. All right, so solving linear and quadratic equations algebraically. So the important thing to understand, in order for something to be an equation, what symbol does it have to have in it?
Equal.
Yeah, it has to have an equal sign. You can't solve this. How would you solve? There's nothing that it's equal to. Right? So in order to solve it, you can have something like that on one side, but then you need to put it equal to something on the other side. So an equation is when you have an equal sign between two different expressions. Generally, x is used as the variable quite a bit as your independent variable. You don't have to, but generally when we want to graph things, x and y are the two letters that we kind of stick to. So when we are, we'll talk about different kinds of equations in a minute, but for now, that's all you need to know about an equation. If I ask you to solve an equation, that means I want you to find the value, or could be values, of x that make it true. Right. For linear equations, generally the most common cases there is one answer. Right. So something like this equation up here, there is only one answer that would make that equation true. And what would x be in that one to make it true? 1, yeah, because 3 times 1 is 3, and 3 plus 2 is 5. And that's the only number. So now I said that having one answer or one solution to an equation, that is the most common thing that can happen, but there are other things that can happen. You can have an equation that's called an identity. Okay? And when you have an equation that's an identity, it's going to look more like this one. Okay? And we'll start to solve it, and let's see what happens. Okay? What's going to happen when we solve it is it's going to end up that any number is going to be a solution. So you could plug in anything you want for x, and it would work. And let's see why. On the right-hand side, what would be the first thing that you'd have to do with the 3 that's in front of the parentheses? Yeah?
Distribute it.
Yep. You distribute it out, and you get 3x plus 3 minus 1. Okay. And then on the right-hand side, when we combine like terms, 3 minus 1 is going to give me how much? 2. So what do you notice just happened there? Yeah, you get the same thing on the left and on the right. So some people may say, well, now you'd put all your x's on one side. So you could, if you subtract 3x from each side. Well, you end up with 2 equals 2. If you end up with an equation where all the letters have canceled out, and you have the same number on the left and on the right, that's what makes it an identity. So you could plug in any number for x and it would work. Okay, so not as common of a situation, but that can happen if you have exactly the same thing on the left and on the right. Okay, that's an identity. So a conditional equation, that's the more common type that comes up. That's an equation that is true under the right conditions. Okay? It means that there's usually a number or numbers you can plug in that make it work. But it's not true all of the time. Like I couldn't just plug in 12 for x and it works. What would be the condition that x has to be to make that one true? 5. Yeah, x would have to be 5. Yep. And is there any other number besides 5 that you could plug in and get 10 as the answer? Yeah?
-5?
No, 2 times -5 would give you -10, so that wouldn't work. Is any other number you can multiply by 2 and get 10? No, yeah, there's no other number. So that's a linear equation. It only has one answer, and the answer is 5. Okay, it's called a conditional equation. So what you might have to do sometime, I ask you to check your answer or verify your answer. That means to take whatever number that you got, or the number that you're given if they give you one, plug it in for x, and see if you get a true statement. Okay, so that's what verify means. Take the value that you found, or you're given, the one you're given, plug it in for x, and see if you get a true statement. So in the example that they're giving us, they want us to verify that -2 is a solution. So if -2 is a solution, when I plug in -2 on the left side and I do everything out, what am I going to end up with when I do all of this out? If -2 is a solution.
You get 0.
I should get 0. Yep. All right, so let's see what we got. So whenever you plug in a number, you should always put it in parentheses. And I'll show you on the calculator what happens if you don't. Okay, I'm going to put a question mark above that equal sign because we don't know. That's what we're trying to figure out. Okay, when you cube -2, what should you get?
-8.
Yeah, you should get -8. Now, on this one, whether you do -2 cubed or you put it in parentheses, you will get the same answer. All right, and that's because the exponent was odd. But let's say you had to do like -2 to the 4th power. Okay, watch what happens. -2 to the 4th gives me, when I type it in that way, it gives me -16. And when I type it in this way, it gives me +16. Okay, so what it's doing in the top one is it's raising 2 to the 4th power, and then it's throwing the negative in front. In this one, it's raising the negative and the 2 to the 4th power. Okay, with an odd, again, it doesn't make a difference, but you should always put it in parentheses. Okay, so -2 cubed gives me -8. And what's going to happen here with -2?
Just adding.
Yep, it's going to become +2. Okay, and what's -8 plus 2? It's -6. And -6 plus 6?
0.
That's 0. Okay, so we got 0. What does that mean about -2? Yeah, so we verified -2 is a solution. And there's nothing else to write other than just showing that work. So yep, 0 equals 0. Okay, if I had gotten something like 0 equals 5, well, that would be a problem. That would mean -2 is not a solution. Okay, so you got to get the same number on both sides when you're verifying. Any questions on that? Okay. All right, so what does a linear equation look like? So a linear equation looks something like that. So this is a linear equation. 3x plus 2 equals 0. Or it could be something that could be rearranged to look like that. Right, let's say you had 2x plus 5 equals 3. is there a way that I could rearrange this so that it looks like what's over on the left? Yeah, what could I do on both sides?
Subtract 3.
Yeah, if I wanted to get it equal to 0 for whatever reason, I could subtract 3 from both sides. Now it's equal to 0 on the right. And I have 2x plus 2 on the left. So even though this didn't look like a linear equation because it wasn't equal to 0, you could rearrange it so that it is equal to 0. Okay, but the key with a linear equation is when you have a variable, you can't have any exponents on it. Right? If you have something like 3x squared plus 5x equals 0, that's not linear. Okay. What does this 2 make the equation?
Quadratic.
Yeah, it makes it quadratic. Okay, so you can't have any exponents except x to the first power. Right? And that's what the exponent always is on x if you don't write it. You can always pretend like there's a 1 right there. All right, so looking at this equation, are there any x's that have exponents other than a 1? No. So this is a linear equation. It's a lot more complicated than just a number times x plus a number equals 0. But if we simplify it, we could make it look exactly like that. All right, so let's see if we can just go through and solve this. What would be my first step? I'm going to have to do it on the left-hand side twice. Yeah, I'm going to have to do the distributive property twice. Okay, so let's distribute all of that. Christian, can you tell me what I get if I distribute out the 2 and the 3?
We have 4x minus 6, and then plus 3x plus 3.
Plus 3? Yep. 5x plus 2. Okay, perfect. So we distribute everything out. What's the next thing I could do on, I got to do it on the left-hand side. There's a little bit we can do on the left side first. Something I would take care of before we move anything from one side to the other. Yeah?
Combine like that.
Yeah, I would combine all the like terms on the left. Okay? Ricky, can you tell me if I combine all my x's on the left, what's that going to give me? 7x. And how about negative 6 plus 3? Negative 3. All right, so now in this problem, the goal is to solve it. In order to solve this, we don't want to get it equal to 0. Okay, we want to get all the x's on one side, and we want to get things without x's on the other. This is just what a linear equation can look like. So if you could rearrange this to get everything on one side and have it look just like that on the other side, then that just means it's a linear equation. It's not necessarily how you solve it. All right? But that's just what a linear equation looks like. To solve it, let's put all the x's on the left and let's put all the numbers on the right. We already said it's linear because there's no exponents other than a 1. So we already know that. How would I bring all my x's to the left?
Subtract 5x.
Yep. So subtract the 5x. And at the same time, so we don't have to write it twice, we can just move the 3 to the other side. How would we move that negative 3?
Plus 3.
We'll do a plus 3. Plus 3. So that's gone. And what does that leave me with now?
2x.
So I have 2x equals 5. And again, if I wanted to prove that this is linear, all I would do would bring the 5 to the other side, and I could say now it looks exactly like that, so it's linear. But that's not how to solve it. Okay, to solve it, we just want to divide each side by what number?
2.
2. So divide by 2. And unless they ask for a decimal, you don't need to. You just leave it as x equals 5 divided by 2. Okay, so not really a problem. I would start out with in Algebra 1 solving linear equations, but hopefully you guys are comfortable with all those steps. Distributive, combine like terms, adding, subtracting, multiplying, all that stuff. Okay. Any question on that? Now, let's take a look at solving an absolute value equation. Okay, an absolute value equation is going to look, let me show you an example, something like this. Okay, it's very, very similar to what we did before, but we're going to have to split this into two problems. And the reason we have to split it into two is because think about something like this. There's two numbers that could end up where I just circled that have an absolute value of 6. What are the two numbers that both have an absolute value of 6? Yep.
Plus or minus 2.
Yeah, it would be plus, so x could be plus or minus 2, because what's inside here has to either be plus or minus 6. Yeah. So if you plug in a 2, you get 6 inside the bars. If you plug in a negative 2, you get negative 6 inside the bars. Either way, those both have an absolute value of 6. So we got to look at how can we get both answers. And that's what I'm going to show you guys. So we're going to split it into two problems. The first thing we have to do, though, before we can split it is isolate the absolute value. Okay, so what does that mean? Well, in both those problems that I gave you a minute ago, the absolute value was already isolated. Here's an example where it's not. In that problem, the absolute value is not by itself. There's something on the outside of the bars that we first have to move to the other side. So when you have something like that, it doesn't even matter. Oops. I just wanted to make a black rectangle. There we go. It doesn't matter even what's inside there. Okay? You're not even focused on what's inside there at all. All you're focused on is taking this 2, this times 2, and getting it on the other side. So how would you get that times 2 on the other side? Yeah, yes. How'd you get that times 2 on there? Yeah. Yeah, you just divide by 2. So divide by 2, divide by 2, and now the absolute value is by itself. Okay, but that's the first step. You have to make sure you isolate the absolute value. Once you isolate it, then yes, it's important what's inside there because we're going to split it into two problems. So the first problem we're going to split it into is basically going to be just take out the bars. It's going to be exactly what the original problem was. You're just not going to copy the bars down. For the second problem we're going to split it up into, we're still going to copy it down without the bars, but we're also going to change the sign of the number. That's what negate means, just a shorter way of saying that. We're going to change the sign of the number on the other side. So if originally it was equal to a positive 5, we're going to make it equal to a negative 5. If it originally was a negative, when we negate it, it's going to be a positive. But in both equations that we copy down, without the bars, okay, the bars are gone.
What does this say right after value?
Absolute value bars.
Oh, bars.
Yep. Okay, so I'll leave that up while we do the first problem. I'm going to do it off to the side because I have some more space over here. So Okay, so first step, split it into two equations after isolating the absolute value bars. Okay. Is there anything that is outside the bars? No. The absolute value bars are already by themselves. I don't care what's inside. I just don't want anything outside. Okay. So let's split it into two. So my first equation is going to be exactly the same as the original problem, just no bars. So what would be my first equation? Yeah.
2x plus 3 equals 1.
Yeah. Either what's inside here can come out to the number 5, and that'll have an absolute value of 5. Or what's inside here could also come out to what other number?
-5.
Could come out to -5, and that would also work. All right. Now we solve each equation. So subtract 3, we get 2x equals 2. And that means x is going to equal how much? 1. Yep. So divide each side by 2. So that's your first answer. X equals 1. Or, there's also another answer. So subtract 3 from both sides. -5 minus 3 is going to give me...
-8.
Yep, -8. Divide by 2. And we get x equals
-4.
-4. Yep. That's pretty much how we solve an absolute value equation. Any question or no? Okay. What if I had something like this? Absolute value of, I'm not going to go through and solve the whole thing. I just want you to look at that. Absolute value of 2x plus 1 equals -4. Anybody notice anything about that one? Yeah?
The solution is a negative.
The so you think there is some number that would
I mean, like the result is a negative.
on the right side?
Yeah.
Yeah, the number on the right side is a negative. Okay. So what do you think would happen here when we try to solve that? The absolute value of 2x plus 1 is going to come out to -4.
So there's just no solution.
Yeah, that's a no solution. You can't take the absolute value of something and ever have it come out to a negative number. So you could try the method that I gave you on this problem. You could split it up and you'll get answers, but they won't work. Okay? You can never have the absolute value equal to a negative number. Now, what if I had something like, let's say, -6 plus the absolute value of 2x plus 1 equals -4. Would you look at that one also right away and just say, oh, its absolute value equal to a negative? No solution.
I would.
No, why is this one's okay? How come? Yeah.
When you isolate the 6, isolate the absolute value, that 6 is like +6. It's
Right.
+2.
When you isolate the absolute value, you're going to do a +6 on each side. So that number on this side, it's not going to be a negative anymore. So just because you see a negative there, it doesn't always mean there's no solution. Is the absolute value by itself? If it is, then okay, there's no solution. But if it isn't, get it by itself, and then maybe that negative will go away. Any question on that? All right, so let's take a look at a mixture problem. So a mixture problem is going to end up with two equations that we have to solve, kind of like absolute value. But we're going to have to figure out what those equations are. And to figure them out, I'm going to give you kind of like a template that you can plug into once you read the problem and you know the numbers that you're working with. Okay, so to give you kind of an idea of what we're going to do, when we're doing a mixture problem, you're generally going to be taking two things and pouring them together to make a third thing. So let's say, for example, you had like rubbing alcohol and the strength of it was 70%. And then you had another jar of rubbing alcohol and the strength of it was 90%. I want to mix the two together to get maybe, so I got a 70 and I got a 90%. Let's mix them together to get 82%. So I want to get something in the middle. So I want to get 82%, and I want to have exactly 10 gallons of it when I'm done. So I need 10 gallons of 82%. How much of each would I mix together to make that happen? Like that, so that's what we're going to figure out. So there's two things going on there. First thing is, I told you I wanted 10 gallons. Okay, so that equation has to do with the amounts. However much I use from the first solution plus however much I use from the second solution, when I mix them together, I need to have 10 gallons when I'm done. But I can't just pick like 5 and 5. If I do that, I'm not going to get the right percentage. I said I wanted exactly 82% rubbing alcohol. So that's where the second equation comes in. And that has to do with the concentration. And it's pretty much, it's three different things. It's the concentration times the amount for the first solution. Then it's the concentration times the amount for the second solution. And that's equal to the concentration times the amount of the final solution. The concentration will always be a decimal. So for example, 70%, you'd have to convert that to a decimal. So 70%, what would that be as a decimal? 0.7, yeah, be 0.7. Okay, so the first equation is for the total amount of solution you want to have. The second equation takes into account the concentration of the solution. Okay, and as long as we have those two templates, all we really have to do is plug into them. So what this is going to result in is it's going to end up as a system of equations. A system of equations means you have two equations. Each equation has two letters. Right? And there's different ways we can solve systems, but we're going to use substitution. People remember substitution a little bit? Okay, so we're gonna do substitution when we get to that step. All right. Everyone have those two formulas? Okay. So now let's try a problem. So we have two different solutions. I'm going to call them solutions A and B. Because they're called solutions A and B, they kind of naturally already have variables. So I'm going to use those as the variables in my problem, A and B. So I'm going to say let A be the amount of this solution. So let A be the amount of the first solution, and let's let the letter B be the amount of the second solution. So A will be the amount that we use of the first solution, and B will be the amount that we use of the second solution. Okay, when we mix the two solutions together, I want to end up with 15 liters. That's the amount of stuff that I want to have. And I want the solution to be 12%. The final solution has to be a number that's between the two you started with. You could never mix these together and get 50% because you didn't start with one that was stronger. Okay, so we're going to mix them together. We're going to get 15 liters of the 12%. Okay, so let's figure out how much we need from each solution. Okay, first equation. The first amount plus the second amount has to equal the total that I want to end up with. How are we representing how many liters we use of the first solution? Yeah, A liters. That's how much we're going to use from the first solution. So we're going to fill in an A everywhere that you see the amount 1 on the board. Okay, so A plus, now I need to know how much am I using of the second solution. How are we representing how much we're going to use for the second one? Yep, B, yep. And when I mix the two together, what's going to be my total amount that I want to end up with? 15 liters. Okay, so there's your first equation. That by itself is not enough to solve the problem, because there's lots of answers to that. A could be 1, B could be 14. A could be 10, B could be 5. All those add up to 15. But now I have to make sure that I get the right strength, 12%. Okay, so we're going to have concentration times amount, concentration times amount, concentration times the total. Okay, so let's set that up. Concentration times amount, concentration times amount, final concentration times the total. Okay, so this is going to represent solution A. This part represents solution B. And this part represents the final mixture. So let's start with solution A. Concentration times amount. What's the concentration of solution A? 10%. And how are we going to put it in as a number in that formula? 0.10. Okay, so concentration times, now we have amount 1 again. We already know what letter we're using for that. What's our letter for amount 1? A. Okay, next solution. What's the concentration of solution B? 0.25. And how much of that solution are we using? B. Now the final mixture. What's the concentration they want us to end up with? 12%, which is 0.12. And then the total amount of liquid when we're done. How much do they want us to end up with? 15. Okay, so let's simplify that a little bit, and that'll give us our second equation. 0.10 is the same as 0.1. So 0.1A plus 0.25B. So there's not really a lot of simplifying we can do there, but on the right side, we can do out 0.12 times 15. Right? And can somebody tell me what does 0.12 times 15 come out to?
1.8.
What is it? 1 point what?
1.8.
1.8. Okay. So there is our second equation. So that's equation 1, that's equation 2. Now we need to solve. Okay, this is a system because we have 2 equations with 2 letters. And earlier I mentioned a method you could use. Does anyone remember one of the methods I said you could use to solve this?
Substitution.
Yep, substitution. I would definitely work with equation 1 because with substitution you need to get a letter by itself. We can do that in equation 1 pretty easy. Okay. What letter do we want to get by itself in equation 1? It doesn't matter. A. So we're going to get A by itself. So if we got A by itself, what would be in that box?
15 minus B.
15 minus B. Okay, so now once we know B, all we have to do is subtract it from 15 and then we have A. Okay? But we got to get B first. Okay, what am I going to do with the information that's in this box? This is the substitution part. Yep.
We're just gonna plug it in
Yeah, where are you going to plug it in?
for A.
For A, in which equation?
And second.
Yeah, in the second equation. So take that information that we just got, and in parentheses, we're going to change A to what it says A is, 15 minus B. And if we do this step right, there shouldn't be 2 different letters in the problem anymore. It should be down to 1 letter. You might see that letter more than once, but it should be the same letter. It's 0.1 times, and instead of A, we're going to fill in 15 minus B plus 0.25B equals 1.8. And now we only have 1 different letter. We just have a B. Right, and now it's kind of like what I showed you guys earlier, solve a linear equation. Okay, what do I have to do with the 0.1?
Distribute.
Yep, distribute that out. 0.1 times 15 is basically dividing it by 10. So it's 1.5. Minus 0.1b plus 0.25b equals 1.8. All right, what can I do on the left-hand side now? Yeah. Yep, perfect. I can combine like terms. Negative 0.1 plus 0.25 is going to be plus 0.15. Okay, you just use your calculator to combine your b's together. Negative 0.1 plus 0.25. All right. What would I do next to get the b by, well, to get the b term by itself on the left? Yep.
Subtract 1.5.
Yep. Subtract 1.5. What's 1.8 minus 1.5? 0.3. And my last step to get b by itself. Divide, say it one more time.
Divide by 1.5. Yeah. Oh, 0.15.
0.15, yeah. I know what you meant. So divide by 0.15. So 0.3 divided by 0.15, that's the same as, if you want to think of it easier without decimals, 30 divided by 15. 2. Okay. So I need 2 liters of solution B. And now I know that B is 2. Take a 2 and fill it in right there. So how many liters do I need of solution A? Yep, 13. There you go. So if you mix 13 liters of solution A, 2 liters of solution B, you'll end up with exactly 15 liters, and it'll have a concentration of 12%. Okay, so that's pretty much the same setup every time you do one of those problems. Set up your 2 equations, use substitution to fill it in, get your first answer, and then you go back and get your second answer. Okay, any question on that? Okay, so that's called, again, that's a mixture or concentration problem. So let me see. What's that? All right, so the last thing we're going to take a little bit of a look at, and we're going to look at it in a few different sections, is looking at an equation that's one step up from linear, and that's a quadratic. Okay, when something's a quadratic, what's the highest exponent in it? Yeah,
2.
it's a 2. Okay, so quadratic equations are going to look something like this. ax squared plus bx plus c. Now, you can plug anything you want in for a, b, and c, but you can't plug in a 0 for a. Because what would happen if you filled in 0 for a? Yeah, that would become linear. If you fill in a 0 for a, you're going to wipe out that first term. And now you're left with bx plus c equals 0. That's exactly what we said earlier that a linear equation looks like. So what our goal is when we have a quadratic equation, if we can, we want to break it down into linear equations. Those are the kind of equations we've already been practicing how to solve. In order to take a quadratic and break it down into linear, you need to factor it. Okay, so if you don't remember factoring from Algebra 1, I'll put up a chart real quick, but I refer to this as I call that the middle. That's the sign of the middle. And I call that one the constant. I'll just abbreviate them M and C, middle and constant. And if you know those two signs, it gives you a hint at how to factor the problem. There's 4 different cases that you can have. You could have positive for the middle and a positive for the constant. You could have, let's say, let's do a negative and a positive. You could also have a negative and a negative. And what else could you have? Yeah, positive and negative. So when you set up factors, you're going to have something like this. These are your factors, the sets of parentheses. If you have 2 positives, when you factor it, you're going to end up with a positive and a positive. Yeah, I can't tell you anything else because I don't know the numbers, but I can tell you it's a positive and a positive. If you have a negative and a positive, does anybody know what your 2 signs are going to be?
Negative,
Well, if they were a negative and a positive, then when we multiply this number times that number, a negative times a positive would give me a negative constant. So we got to get a positive constant, but it has to be a negative times a negative. And then the last 2 cases, it's one of each. This is positive, negative, and that's positive and negative. Okay, so if you don't remember, again, from Algebra 1, hopefully that kind of reminds you about your signs. Okay, so let's try this one. So right away, we can put 2 sets of parentheses. And when you are factoring, you always want to make sure it is equal to 0. This problem already is. All right. So what's going to be my signs inside the parentheses based off of the middle and the constant? Right, it's going to be a positive and a negative. Okay, it might be positive, negative, it might be negative, positive. We might have to switch it. It just depends on what we use for numbers. Now, what you put here and what you put here have to multiply together to give you 2x squared. So what could I put on that line and that line? So when you multiply them, you get 2x to the second power. So a 2 and a 1, so 2 times 1 gives me the 2. How about the x squared? Yeah, just put an x on both. So we need a 2x and a 1x. Yep. Okay, we already got our signs. Now what goes here and here are two numbers that multiply to give me 3. We've already taken care of getting the negative. That was taken care of by positive, negative. But we need two things that multiply to give me 3. Which would be what? Yeah?
1 and 3.
All right, so let's try 1 and 3. We already know we've got the first and the last one, right? The tricky one sometimes is the one in the middle. Okay, so let's see what happened. What's 2x times negative 3? Negative 6x. And what's 1x times 1? 1x. What's negative 6x plus 1x?
Negative 5x.
Okay. Is that what I had in the middle? No, it's the wrong sign. So that means we just have to switch what? We just have to switch the signs. Make that a positive. Make that a negative. Now if you check it, 2x times positive 3 is positive 6x. And 1x times negative 1 is negative 1x. And 6x take away 1x is 5x. That's perfect. Okay, so that's the hard part. Now, by factoring it, we've simplified this from having an exponent of 2 to now just having exponents of 1, which makes each one of these linear. Okay, so we got rid of the exponent of 2. So now, set each factor equal to 0 and solve. Okay, so my first factor is 2x minus 1. Set it equal to 0. My second factor is x plus 3. And set that equal to 0. Okay, so in your first factor, how would I get x by itself there?
Add 1 to both sides.
Add 1 to both sides. Okay, so 2 times x equals 1. And my last step to get x by itself. Divide by 2. Yep, so x is a half. And in the second one, I only have one step to get x by itself. Minus 3. That's gone. And what does x equal there? Negative 3. Yep. Okay. Any question on how we turn that quadratic basically into two linear problems by factoring?
May I see the chart for a second?
Yep. Now the problem with factoring is sometimes you can't find two numbers that multiply to give you something and then add to give you something else. So when you're solving a quadratic, does anybody remember something else you can use besides factoring if the numbers don't come out nice? Yeah? Yeah. In that case, we have to use the quadratic formula. Okay. Does everybody have that chart?
Oh, almost done.
Okay. Thank you.
Okay, and that'll be the last thing we look at. So if factoring doesn't work, we can use the quadratic formula. Okay, that's the quadratic formula. The A, the B, and the C come from here, here, and there. The a is the number that's in front of the x squared. The b is the number that's in front of the x. And the c is the constant. Okay, so that's an opposite of b, plus or minus. And the reason the plus or minus is there is because you're always going to get two answers. By putting a plus and a minus, that gives you the 2. And then under the square root is b squared minus 4ac. That part under the square root is called the discriminant. So if you hear me refer to the word discriminant, it's just the small part of the quadratic formula under the root. And that's all divided by 2a. All right, so just like I mentioned before, in order to use quadratic formula or factoring, you have to get it equal to 0. You have to get it equal to 0. So if it's not equal to 0, then rearrange it so you get 0 on one side and you get everything else on the left. Let me see. All right, so what I'm going to do, I'm just going to make up an example that uses quadratic formula. If we wanted, I could do the same problem we already did that factored, or I could make up a different one. Anybody care?
No.
If we do it? Maybe I'll just make up a different one then. Okay. Leave that up there. Solve. Let's do 2x squared minus 5x plus 3. I think that's different than the one I did, right?
Yeah.
Oh, it's pretty close though. Let me just change one number then. Make it a little different. Make it plus 4. Before I start to solve it, what I'm going to do is I want to check to make sure it has a solution, because sometimes if I just make up a problem, it won't work. So I'm going to just quickly check. It's going to be 25 minus 4 times 2 times 4. I'm going to make that number at the end a little smaller to make sure this is going to work. Let's make that a plus 2. That should be okay now. All right, so let's just identify A, B, and C. Okay, what's A? A is going to be right there, so that's 2. What's B? -5, that's right there. And what's C?
2.
It's also 2, because it's the number at the end. Okay, so let's fill everything in. Okay, what's the opposite of B?
5.
5. Plus or minus, and what's going to go under the square root?
-5 squared.
Yep, what's -5 squared?
25.
So 25 minus 4 times
2 times
2 times 2.
2.
Yeah, it would not have worked out the way I wanted if I left the number that I had before. This is okay. All right, and we're going to divide all of that by 4. Yep. So we get 5 plus or minus. What's 4 times 2? 8. What's 8 times 2? So I end up with 25 minus 16, which is how much?
9.
9. divided by 4. And what's the square root of 9? 3. So in this case, the square root came out nice. A lot of times it might not, right? So if we had square root of like 10, we'd just stop right there and leave the answer as 5 plus or minus root 10 over 4. But because the square root of 9 simplifies, we're gonna go ahead and simplify it. Okay. So we get 2 answers. What's 5 plus 3? So we get 5 plus 3 is 8 divided by 4, which is, so we get 2. And now we do the minus. What's 5 minus 3? 2. And 2 divided by 4? 1/2. Okay, so for quadratic formula, those answers came out very, very nice. All right. Any questions on that? All right, so that's 2.3. So we still got, you got about 20 minutes or so. So I can give you a little time to start the homework. Let me just double check that. 4. 18. I'm just going to change 19 to 18. Let's do that one. 37 and 38, those are quadratic formula. 58 is a mixture problem. And 52 to 54 is a rectangle problem. So it has to do with like the perimeter of a rectangle. Okay. So again, you got about 20 minutes, so you can use the time to get started on that. Reminder, we'll have our last test before progress reports on Friday. And I'll be after school on Thursday if anybody needs to come by for extra help.